Okay, so you want to take a look at 3.10, last question. Okay, let me get my pen going. All right, let's read through the question. It says that in 2015, 43.5% of all smartphone users in the US were iPhone users. In a recent random sample of 5,650 smartphone users, 2,634 were iPhone users. Use a 99% confidence interval for the percentage of all US smartphone users to test whether or not 43.5% of all US smartphone users were iPhone users. Okay, so what I want to do to start off with on any of these problems is to take the information in that paragraph and write it down in our math symbols so that we know what numbers go where. Okay, it's usually not a good idea to wait until you're working on a piece of the problem and try to figure out which number you want to grab, because then it can get confusing. Okay, so the year is a number, but I don't really need to write that down. That's not going to be like a piece of information we need. Okay. But in this year, it was 43.5% of all smartphone users. So this is a percentage of my population, okay, in the past. And now more recently, we take this sample. So this is our sample size. So N is 5,650. And in that sample, 2,634 were iPhone users. So we typically call that X. Okay, so this is my sample. Okay, I want to use a 99% confidence interval to test whether or not it's actually 43.5% in the population. So we want to test to see if my population proportion P is 0.435 or 43.5%. All right. So now let's go ahead and start the question. The parameter, remember, is the summary piece of information for the population. Okay, so that's going to be P. Just to give you, a little bit of contrast here, P hat, which is X over N, is the measuring the same thing except in the sample. So it would be the percentage of iPhone users in the sample. Okay, so now what's the correct wording for my population parameter P? I can actually pick that right out of the paragraph, right? This is going to be the percent of all smartphone users in the US that were iPhone users. Okay, and again, that's the thing that we want to check, right? Use a confidence interval for the percentage of all US smartphone users to test whether or not they're iPhone users. Okay, so the parameter is the percentage of all smartphone users that are iPhone users. Okay, if I leave out the percentage part, that's not P anymore, then that's my actual population, right? That's the actual people. P is just one number, so it's that percentage. Okay, whether or not somebody is an iPhone user, the answer to that question is yes or no, so we're looking at qualitative data. Okay. The conditions that we have to check are that NP is bigger than 10, and 1 minus P is bigger than 10, capital N is greater than 20 times little n. Okay, so when we go to check those assumptions, I'm sorry, we want NP hat. When we go to check those assumptions, since P hat is X over N, if I multiply that by N, I just get X. So the easier way to do this, rather than to plug in my n, compute my p hat, and plug in my p hat, is just to say that np hat, this is x. Okay. And this thing here is n minus x, or the number of yeses. Or sorry, x is the number of yeses, n minus x is the number of no's. So this is 2634, and this is 5650 minus 2634. Okay, which is 3016. Okay. So here I have 2634, which is greater than or equal to 10, right? That's the thing I'm going to check. The number of people that are not iPhone users in our sample is 3016, which is definitely bigger than 10. Okay, so my sample is plenty large, right? Thousands of people, that's plenty. The next thing I need to check is make sure my population is big enough. I don't know the actual number of iPhone users, of smartphone users in the US, but I know that it's a lot. Okay, it needs to be more than 20 times our sample size. So the thing I'm going to plug in here is 20 times little n, okay, which is 20 times 5650. And if I compute that out, I get 113,000 people. Okay, which is a lot, but I know that there's definitely a lot more than 113,000 people that use a smartphone in the US, right? I'm sure it's millions and millions. Okay, because we have to enter a number, because this is, if this was just on paper, I would write, I don't know what the population size is, but we can just assume that it's more than, so we can safely assume it's more than 113,000. But since we have to enter a number here, we're just going to enter in this 1 million that they tell us. Okay, that's certainly greater than or equal to that 20 times little n. Okay, now let's go down a little bit. The procedure that we're going to use to create our confidence interval is that 1 proportion z interval. Okay. For the interval and point estimate, okay, for the point estimate is going to be p hat, right? That's going to be the proportion that we get in our sample. And I could compute it directly. Well, I erased it now. I could compute it directly from the information I had doing that x over n. But when I run this 1 proportion z interval test, it'll compute p hat for me, as well as the interval estimate. Okay. The interval estimate is an estimate for p. P hat I know exactly, right? That is a number that we're absolutely sure of, and I don't need any sort of fancy techniques or calculator formulas to figure it out. P is the one that we don't know, and that's what we're estimating. Okay, so let me get out my calculator. So I'm going to go to Stat, go over to Tests, and go down to 1 prop z int. Okay, make sure I get the right one, not 1 prop z test. Okay, should write this stuff in ink that doesn't erase. Okay, so the x was 2634. The n was 5650. And we wrote that down earlier, so if you're just reading off what you wrote down, that'll be nice and easy. And it's a 99% confidence interval, so I want to make sure that that C level is 0.99. So I hit calculate. Okay, so now I can see my p hat. This gives it to me as a decimal. Here it says leave your answer as a fraction. So I have to say, oh, okay, well, when I entered in my information, p hat is x over n. X was 2634, n is 5650. Okay, that's the fraction that I'm going to enter in then. You don't need to simplify that fraction. Okay, so this is a correct fraction. It's not in simplest form, right? It's not, you could reduce the prime powers in there, but we don't need to do that. Then our interval estimate is going to be 0.4491. It says to round to 3 decimal places, so that rounds to 0.449. Okay, to 0.483. Okay, so now our conclusion, we are 99% confident that what we're confident about is that our population proportion P is in this interval. Okay, and remember that's the percentage of all smartphone users that are iPhone users. So we're 99% confident that the percentage of all smartphone users that are iPhone users is between 44.9% and 48.3%. Okay. And remember back here, in the past, it was 43.5%. And now we're sure that it's in this range. Okay, if I just don't need to do this, but if I were to draw a little line graph here, here's my interval, 44.9% up to 48.3%. Okay, in the past it was 43.5. That's just a little bit over. Okay, so we're 99% confident that the actual value of P is in here. So this isn't it anymore, right? That we can be confident that it's moved up. So since the claimed value of 43.5% is not in the interval, right? The confidence interval is above that claimed value. Then we have statistically significant evidence that the percentage is higher or bigger than that claimed value. All right. Any questions on that one?